A warm greeting to everyone. I am RAJASEGAR ANAMALLEY, PhD student from UKM and supervised by Associate Professor Dr. Satira Abidin from FSK UKM. Would like to present my research entitled The Effect of 17-beta-hydroxycholine on Cardiac Sodium Potassium ATPase Expression, Cardiac Structure and Function in Heart Failure Rat Model. As everyone knows, heart disease is not a new topic in our community. Nevertheless, it is an increasing alarming rate. In 2020, 17% of overall cause-specific death was caused by ischemic heart disease. Heart failure was caused by an abnormal enlargement or thickening of heart muscle by oxidative stress. This will increase the cardiac myocyte size, eventually lead to cardiac hypertrophy. Hence, this condition will end up in heart failure, which the heart failure to pump enough blood as it should be. Ladies and gentlemen, now I would like to briefly explain about our extraction compound from cerebral odolum tree, or also known as suicide tree. 17-beta-H-neurofolin is firstly discovered by the Fring researchers. It has similar compound as cardenolide glycoside. 17-beta-H-neurofolin also been proved to reduce viability of cancer cells by stimulating apoptosis. Added with this, previously our lab also proved that 17-beta-H-neurofolin, which is isolated from the cerebral odolum tree, enhances left ventricular contractility in normal and falling hearts ex vivo. This is our research methodology, research objective. Now, let me to explain about our methodology. The compound 17-beta-H-neurofolin was extracted by Fring, followed by animal preparation. Total of 40 male Vista rat was used in this research. Heart failure was induced by giving 10 mg per kg isoprenaline subcutaneously for 14 days, and the vehicle was given saline. The treatment group was given 5 mg per kg 17-beta-neurofolin orally for 14 days, whereas the positive control digoxin was given 5 mg per kg orally for 14 days. The cardiac function was measured by measuring blood pressure, ECG, LVDP, and the blood serum was subjected to measure ProPNB, followed by the cardiac structure damages investigation by measuring cardiomyocyte size and collagen deposition. The protein expression of calcium handling protein was also measured. Now, let us concentrate in our result and discussion. First and foremost, hemodynamic measurement, which is heart rate was increased in heart failure model significantly compared to the vehicle group. However, it is not significant compared to the treatment group. The systolic blood pressure was increased during heart failure induction period. However, SNA-209 was able to reduce systolic blood pressure in treatment group significantly after 14 days. Next, we would like to explain the heart mechanical function, which is the cellular injury markers, ProPNB. The ProPNB was increased in ISO group while it is reduced in treatment group. It is statistically significant. This is because due to the end of the antioxidant presence in SNA-209, which able to improve the cell membrane leakage and stability. LVDP, left ventricular developed pressure, which was measured by Langeroff perfused heart method, show reduced in ISO group, indicating the heart was not able to pump and contract. However, this condition was improved in treatment group as SNA-209 worked as a cardiac glycoside able to improve the cardiac contractility. Next, we can see the larger cardiomyocyte size was clearly seen in ISO group. This indicating hypertrophic condition. By this condition was recovered by SNA-209. The effect of oxidative stress by isoprenaline also lead to the deposition of collagens that can clearly see in ISO group. This indicated the black arrow where we can see the deposition of collagen in red color. The cardiomyocyte size and collagen deposition was significantly reduced by SNA-209, probably due to the presence of antioxidant in SNA-209. Next, we will move on into the calcium handling protein expression. By measuring alpha-1 sodium potassium ATPase, SERCA, and NCX proteins, all the protein was reduced in ISO group, but interestingly, SNA-209 able to restore the expression in treatment group. As SNA-209, it is a cardiac glycoside compound which will improve the cardiac contractility by restoring the calcium ion. As conclusion in this study, the left ventricle was hypertrophied, the left ventricular systolic function was deteriorated, and the serum level of anti-proBNP was made increase in all the rats in the ISO and SNA treatment group on the 14 days. This suggesting that the isoprenylene-induced heart failure model was successfully achieved. Interestingly, SNA-209, a cardiac glycoside compound, was able to improve the cellular injury damages by ISO. By ISO recovered the structure damage and fibrosis condition, as well as improved the contractility by restoring the calcium ion in cardiomyocyte. This was highlighting its potential use as treatment for the heart failure condition. With that, I would like to acknowledge my supervisor committee, Associate Professor Dr. Satira Zainal Abidin, Professor Madya Dr. Kamisa Yusuf, Dr. Nurhanan Murni, Yunus from Frame, my funding, and my laboratory members. With that, thank you very much.